Two on duty and one on standby.
Now this tour around the Byworth boiler works of Keighley was instigated by our president, Lawrence Bentley. It's thanks to him that we all met here on the Saturday morning in October. And after GFT to drink, biscuits,
Just said
and
mind the steps,
lovely
so I just
bacon
go the opposite.
sandwiches, all gathered together here. And we were taken around the boiler works by Peter and Brian, and they described in great detail each process in the making of these boilers. And every question that we fired at them, they answered in great detail. Fascinating how these boilers are made. These modern boilers are not the riveted type as a lot of us are used to, but especially welded, highly specialised welding which is involved.
We can walk down there, I haven't locked it. We'll go down at the end. The other thing as well, we make a lot of the parts down in there at the moment. We have to trail the beer on little trolleys, so the idea is that all the spares and the warehouse department will be in that big chunk there, and then we've got this little bridge over there, so anything, twice a day, people are going to be able to then go do a pick, get all the parts we need, put them onto little trolleys, and drag them in and distribute them into different parts of the factory where we need them.
We're just making our way now to the start of the boiler works. It's in here where the flat plate, the boilers stored. The boilers are actually rolled from these thick flat plates, and lots of welding done. So I'll just say no more now, and I just hope you find this of interest and follow us around the works.
Where Byworth first started, a little bit at the top there, which is the main entrance and the reception where all the offices are. And it looks really spanky and nice from the inside. But on the back of here, that's the original part of the factory there, just up them stairs. So that's where Dennis and Evan was starting, that was the first bit. Then they obviously built this bit on, so everything was all, they did the whole process within that bit from this bit at one time. So this is what we call Factory 1. So as we then roll it up into the thing, we've already got the weld preps on, then to put the weld straight onto the sub-arches. So that's, yeah, it's pretty much Factory 1. All the cutting takes place the same, everything's all stacked, the mill surface on, the heating are on. This is what's called this head. The cutter it can obviously when we go down the edge of the plate, so they've cut this on there the other day. This is for a YSX, so it's going to be a 5-ton boiler.
So what is stood on there is actually boiler in the flat before it's put on the rollers like you can see behind him.
And then from that as well, obviously it traces back to the plate. You can see they've put that onto the machine, and then the head on the machine there will angle over, and then they can run down and put that weld prep on. So we've already got the weld prep on. It also flips over, and it can, as it's cutting a hole, it'll do that. So we can put a weld prep on a hole. So it'll do a 360 burn. That's got 45-degree weld prep on the inside of that overshape there. That's where we fit the manhole. We are calling manholes in those. Big personals, dropped out into the boiler. So we cut them. It's supposed to be able to get in down through there. But you've got this one train. So shells that we do just go under the crane. So it's a little bit. We have to grab it with the end of the crane as it comes over. So this one in here. So this is a YSX. It's quite small. This is only a 2-tonner. So the biggest ones we do are 19-ton. It's a little bit. That goes to the shed. So this is the actual shell of the boiler. This is what's called a longitudinal seam weld. So when we go into factory 2, you'll see more of that. But this is a sub-arced on. So the lads will put sub-arc just down there. So again, it's got weld prep on the inside. So that way on. Then they put multiple runs down the inside. And then they'll put capping run down there. razor on the joint. So we're allowed 1/3 of the thickness, 1/3 of the diameter of the boiler plate thickness as a peak, maximum peak, which we obviously try and get away from. So that's a big thing. That's why I've marked, that's my job is marking this. So at 5 points along the boiler, we take it's a little bit old-fashioned, but we take a measurement of the peak heat with like a needle gauge, and then we have to draw that. Then that goes into the document pack, and then in 5 years' time, when they do an inspection on the boiler again, the inspector man gets his thing and then checks it back to my original tracing, and if it's gone like that, then it's so it's quite. And once he's rolled it, that's nice there. He knows he's got his form right. And again, we check the roundness, then we check the peaking, and then it's happy days. You can go through to the other shop. So the dish ends, first up, after the others come in like that, we then flip them over, put them onto the machine. We do quite a lot of cutting on the dish ends as they are. And then from there, we go to this big active butler, so it's a big CNC machine at the bottom. Again, these were all hand drilled at one time, the big radial arm with 2 steel drills. No, that's the maximum shell width. Yeah. We can obviously roll.
Look at the weld on that, blimey.
In diameter. But so what we have to do when the boilers get longer, just make more, call them a strake. This is the shell strake. So if we want to make a boiler that's, well, we'll see some in there. So this is just a single strake because it's a 2-tonner. So the bigger boilers, as you go down, we'll have double 2 strakes on. So then we weld them together on a circumferential welder. That's got a weld prep on there ready for the dished end. So they've got the same prep on, and then we'll put the sub-arc welding into that prep there. So if there's any ends, just depending on what we're going in. So they're what we call 322/20s. So we blow that straight out of solid material, so there's obviously a lot of waste. So all the big lump in the middle disappears. We do try and make it where we nest them together. So we've got 420, 423/20, 322/20, and then we've got 100 150s. And so we try and nest them together so we can, out of one sheet of material, we blow all the different sizes all out of one piece of material. So we've nested it together. So again, it's got like an oxy cutter on that end, and they'll just blow that out of there. But they get an amazingly good finish on it. So as I said, we make absolutely, we make everything here from the pads we weld onto the hot welds out of stainless, all the man rings, man necks, doubler parts, all the bits that go into. A lot of that stuff is made here. The rest of it's all made down the station.
Well, that's showing the manhole covers there, which have been cut from solid sheet steel.
This is what and blow that prep on. Same on the outside. We etch the boiler number on. This is MX1360 1006. Works order number on it. Then it goes from here, we go onto that machine, and Joe will drill all the tube holes in. So these top row, so that's the bottom of the boiler, that's the top, that's your row of longitudinal stairs there, so that's your bars, front and back, all your tube plates in. That's the back of the firebox, so you've got your combustion tube chamber, and then that's got a water space between that and the same as what we've got here, still got water space behind it, and that's all welded in the back. But there's a 1360 that's in the construction shop here. You'll see all that built up. So this is again, shell's been cut, ready to go. This is a YSX5000. So this is into what I call it's like the main heart of the factory. This is factory 2. This is where we do all the main boiler construction. So as I said, this is Friday afternoon. Joe finished this on that Asquith butler there. So he drilled all these 2-inch holes in there using a U-drill. So as I said, those are done on the Messier cutters. But these are all done to well 50.8. So we make them slightly oversized, so we can actually slot the tubes in, and then you bring them down at the bottom of the shop. They then expand those tubes up, get the tube plates. That's where the furnace is going to go in there. You'll see that as we go down the shop. So these are all prepped. Again, this is marked up for a YSX 5000 1002. In here, because we actually met stuff. You can't move for MPs and politicians. So again, into factory 2. So we've got more sub-arcers, we've got a sub-arc arm on here. Sub-arcing head on the end. There's another one in the middle of the shop there that's got a massive pick next to it so we can stand things on its end. So the idea with sub-arc, we've got obviously the weld set that's connected to the head. So we've got wire, it's 4mm wire on there. We then feed the wires on feeding rollers through, comes out of the end there. See that little laser pointer, that points down to the weld so they can track the point on the weld. It feeds the wire out, and then they fill up the little hoppers with flux granules, so it's submerged arc. So the arc is submerged underneath the flux. Obviously, there's no oxygen. When you do it with make, you're obviously taking the oxygen away by putting gas around it. This is done by burying it in flux. As it welds, the flux melts, gives off gas, and then that's what gets the weld. So on here we've got ready prepping. This is the furnace. So what we do is we cut the furnace sections, flat pack, then we roll them, do a longitudinal weld, so they end up like that. Then the next process is we flip them onto the end, and we put them onto that piece of antiquated equipment in the corner. And again, I've got took some videos of it yesterday. I'll show you on my phone later if you want to have a look. So that's like a massive gas burner there. So there's 8 gas nozzles firing gas out of a big massive flame. We heat them up until they're 900 degrees, and then that forming head comes out. And that table spins round, and then we grip the forming head onto the top of the furnace section. It's called a bowling hoop. So this is a bowling hoop. So the idea is that we can have a long section of a furnace, and this has strength to it. So we can only go to a certain length, a certain diameter. The form is straight off of that, and then after much more is right in the diameter, it's something really good strength going. Alright? Yeah, that's it. As you check them, you know that much on it. Yes. And then all the designs have to do something like well, they all go to you. They go back to all your calculations and then go, higher tube, isn't it? For a 2 tonner. So that's, for that 2 tonner shell that we've got. Oh, in the rollers, this is the furnace for it. So that's all been done, checked for roundness. You can see where they've scanned some of the weld, because you can see where they've had the wallpaper paste on it.
That used to take probably.
That sticks out over the boiler, and you see that over there.
Cool. Amazing, isn't it? That. I'd love to do that in my garage. So you know. Yeah.
That's the Wi-Fi 5000, so that furnace is finished, we'll weld that into there. We just then weld it on it, and then swap that in, and just go down the bottom step.
Carousel. that's combustion chamber that's been routed. A few of them were nosy.
Alright, yeah. So she's welded that side, that's all done, and then she's put a root run into there, that's your prep.
That's all MIG.
It's on MIG, but that table spins round, We'll do that on that line, and then we'll scan that well there. She'll do that, quite often do that by hand. Into the tub, and it's used again.
So it's not all lost.
Ultimate recycling.
And then there's a lot of it on the floor, as you can see, but that's how it is. So that's 16.5 tonner. We put it in vertical, and then he's going to sub-arc the tube plate into the end of the shell. That's just gone from, that's been tubed. It's been tubed and everything, and it's gone back on there for a final process, I think.
So we can, I mean, it's a bit more the old-fashioned way of doing it. Is that these are what we call export boilers. So we do an export range, EYX 16600 that. So they've got the old-fashioned tube plates that set in because they're going to export, so they're a bit cheaper. Whereas I say most of the boilers we make now have got dished ends on. So we put the dished ends on with the boiler horizontal, and we can weld them on horizontally. So we spin it around that way. Whereas the tube plates, we need to drop it into the pit on its end, get the sub-archer up, and then weld the tube plates on in that orientation. So it's a bit more of a pain, I think.
And there's a electric turntable in the bottom, so that's spinning that, rotating that boiler down at the bottom of the pit.
This is the rules that's been
Tubes are called then. So you put your head in and look at the tubes, and then the manhole one's on the other side. But you'll see them probably clear. Yeah, double tables. Then the legs dangle off and sit on the chains. And then they've all got harnesses, you've got to strap them onto so they go up and down in these mute things, that thing there. So we've got a load of them, so they stand in there, harnesses on, clip themselves on, and then they go up into the air. I've actually got one stood up in here at the moment, but usually, so when they're welding all the tube ends in and all the bars and all that sort of stuff, they've got to do them in position. So again, the boiler will get stood on its end, and the lads, the main boiler makers here, will then go up in the mutes with the weld sets, and they'll clip onto the mute itself, and then they'll kneel on top of the boiler and weld all the tube ends in. It's a special thing.
Andy, we have...
No. So this is where we have another little section here, so where we make big tea tanks, the blow down tank. So here's what like the climbing the shell, all the fittings, dished ends, and then we start. What? No. So we get dished ends for birdies as well, same as the dished ends on the big boilers. So we can get all these prep ready for all the sides. This off BT0. This is ready to go back in that pit there, and he'll sub-arc that tube plate on into there. So you can see the weld prep there. They put a backing run in it and a root in it already, and then they'll flip it on its end, stick it on in that pit, and then they'll put that on there. But then Mark has done all these other fittings. So these are your level gauges. So you can see this is what's called reversal type. So the burner will blow down there, heat up all this, and then this fella comes back, and then it goes down these tubes. There's only one pass of tubes on this type of boiler. This is an MX. Okay, so the water level, you can see where the gauge cock arms are. So the water level will be there, so you need to keep your tubes covered. So that's massively important, otherwise you burn your tubes out. Okay, and that's what they call the steam space. So the part from there up to the top, that's where the steam that's generated is generated in that bit there. So as I say, that's your furnace. These are what they call stay tubes. All right, so these are thicker. These are 50.8mm OD, 6.35mm wall. The plain tubes that we put in there, 50.8 OD, 3.25mm wall. And then we weld the ends, this end here, but the other end we don't weld. We just expand that, and then as the tubes expand and contract, they can actually slide inside the tube plate, and they get less cracking. These are what are called stay bars that Pete was talking about earlier on, when we talked about the weld prep. So these have been welded in.
That's the MIG on the arm, isn't it?
No, they weld that in by hand.
Oh, is that by hand? But everything else is by hand, so it's all freehand. It's not.
So again, all these pads, we cut them, mill them, drill them, tap them, weld them on. All these we make all these down the station works. All these pipe stills. So again, we have to buy a flange. We get a piece of tube again that has to be traceable, so there'll be a number stamped on it somewhere.
That's required, you've got to read it out.
Then we have to weld the flange to the tube. Then we get them kept on shelves down there. And then when the boiler calls for its kit, we deliver all this up to the boiler maker, and then he'll weld all these different things in.
What are them for?
What are these? These are level. Yeah. And then your water gets squirted in there from your from your pump. These have got level probes on them. So again, this is like a safety check that you've actually got water in the boiler. This is a bit more Pete's expertise. And then these are actually where the level probes go. So you'll have Some of them are brass probes. There's all types of different controls these days. These used to be brass probes sat in the water. So you'd high water, low water, and then you've got one that can monitor in between. So you can, if you've got a pump that's got an inverter on it, you can speed pump up and slow it down. It's not just on off. So there's on off controls. There's a million types of different controls these days. It used to be pump on, pump off, not high or low. Whereas now that's more.
Navy, safety valves, Byworth, and then it's just easier to do that, cheaper. We'd end up making a million safety valves and a million ground valves. It's easier to buy with.
So this is Mark's welding. There's one of the main boiler makers. So it's, yeah, nice tidy welding.
Do they ever need retubing?
They do retube them, yeah. And if to, so basically, if to be able to get the weld, obviously this end of the tube. No, I mean, the most common size is 50.8 millimetres, but then the next size up is 63.5, and then we do some boilers for 70 mil. Obviously, the bigger the boilers get, we start using bigger tubes. Yeah, so the 19-ton boilers are like 3.5 tube in it instead of 50.1. Right, so
It smells.
yeah, so we don't want to have to keep millions of different sizes of tubes. I mean, bizarrely enough, the Pete's one's got 44.5 millimetre tubes, which is designed people.
Loads. Because the gas is coming through. It slows it down.
So this boiler's ready. It got its final scan on yesterday. So the scanning lads will come. So this is the the tube you're asking about. What's that thing at the end? That's that bit there.
Yeah.
So that's the end of the combustion chamber. That's the same size tube. So again, they've welded that into the dished end, and they've scanned it all the way around there
Plenty of spare.
to know that that weld is correct.
12 metre length. We've got loads of lengths.
They've obviously welded all the tube staybacks. So these are staybacks. This is a Yorkshireman.
We make workbenches out.
Might be easy to show you up next one. But again, all these have been welded in by hand. So the boiler's been stood up on its end. And Ben, part of it, he's welded all ends there like that. They'll clean them up a little bit, but he'd only finished it on Friday. So stair tubes, and then plain tubes will go into here.
It's good for
We call a mud hole, so that when that's the bottom of the boiler, so they can take a little thing out of there, and any mud and crap that's developed into the boiler, they can take it out through there. And this will end up in a hire trailer. This is another YSX 5000, 1001. So this will end up in an Arctic unit eventually.
Those head holes.
Um,
And then for the bigger mud holes, or any of the bigger wells.
no, just welding in. We're just putting the base doublers on it. This particular one, it's got a what they call compensation plate. So if they've got a big hole opening in it, what they can do is instead of having the thickness of the entire shell, they can put what they call a compensation plate in. So we cut that. It's out of the same it's boilerplate again, but we cut that bent from the top of the boiler if we wanted. Level probes, safety valves, and you take off your crown valve. And this one's obviously got dished ends on, so we've sub-arced the dished ends onto there. So that's your main boiler shell, dished end, sub-arced on. Well, one end, you have to stand on the top, and then we have to lay it down, and then we have to roll it over and do the other end. So to be able to do that, we have to do it with the crane, which is a little bit switchy when it's... The design one was brought me drawings, and the diameter was so big and the length was so long, I worked it out, and I went, well, I can't spin that. So I sent it back, so that made the boiler shorter and a bigger diameter to get the output.
You've never seen 20 volts with a sat down the yard of your life.
This is the furnace again, it's taken straight down to the bottom, it's all in individual parts, all sub-arced together. You've got your combustion chamber, a reversal cell on one end. So again, you burn it low in this line, goes down there, it's still covered in water, so it's heating up the water there, hits the reversal cell, combustion chamber, back in, back down this set of tubes, and then it'll go out of there, and then we'll get into the shop next door. So the hot gases come out of there, reverses again, and goes down your second pass of tubes. And then it goes out of there, and then out to chimney, or through an economiser. So these are...
Why do you need this?
Keep that cooling down. Test that down.
I thought it stiffens up. Because you've obviously the water pressure, so you've got 10 bar, 20 bar, whatever we've got on the PSI, outside of it, that's stiffening, it's giving it extra strength.
We did a 300 psi 18 from the new bank. Yeah, and that had double hoops in it, didn't it? So it had one in the middle of each one as
Yeah,
well.
so the higher the pressure of the boiler, and the bigger it is, or the higher the pressure, the closer these hoops come together. And then we have to put stiffeners on the outside as well. So we had some, we have to cut them out of solid, like 25 mil or something like that. They were thick, and we cut them into like half moon shapes, and then we have to weld them onto the outside of it as well. So again, just to stiffen it all up. Plate on. We weld that onto so the water goes in through that fitting there, and then we put a little deflector plate on so it doesn't blow straight onto the tubes and bars. It deflects it round and puts it back onto the shell. Yeah, these are inspection points, so you can have a look at the tubes. They're all welded on the inside, welded on the outside. And all these, they're all on rotators, so they start pulling electric motor and they can rotate it round to whatever position they want. So they've obviously got to weld each fitting in position. So they rotate it until that's at the top, then kneel down, weld it, and then they'll spin it again, weld it, spin it again, weld it. So each of the welds again, the longitudinal weld, that gets scanned. So these are two strakes that have been joined together. We talked about, you asking about how we make longer boilers. So this is two strakes that have been joined together. So you can see where the circumferential weld is in the middle. So that's been two separate cells rolled together, and then we joined them together and sub-arc welded joints together as well on machine down at the bottom.
These are just tracked as a stop.
Yeah, he'll knock them off. So once he's got, that's just helping when putting them in there, so he can line that tube plate there exactly up to that line. So he'll put it back, so he knows he's got that flat. Because we don't want them. We want them parallel. We don't want them like that or like that or like that.
How does it get out?
How's it get them out? Just tack it back there. Look at it.
Right.
Yeah. So the welder, once you've got the nuts in there, that's drop yours. So no, you're having fire chaps because you won't be able to mind zones. So we get into tubing up department. So this is what these chaps are on with this morning. So this is all. It's had its dish end welded on Thursday. Got scanned yesterday. So we know that it's all right. We can carry on with the next stage. We don't want to put the tubes in until we know that the welds on the dish end are fine. As I said, welded dish ends on is usually good. Touch wood, we don't have to need down or something. So the next stage is putting all the tubes in. So they're on with stair tubes, inner bank and outer bank. You're putting the inner bank stair tubes in here at the moment. So I mean, if you want to move around to this end, you'll probably see a bit better. So these are all loaded in by hand by these two burly gentlemen. If you want a job, come see Brendan.
Get them biceps, triceps.
Plan down there, vertical cell, back up the tubes. So this is the inner bank. So these are inner bank stair tubes. So these are all to weld in. So that's why they have to clean up either end of them. We've cleaned up round here, and then the welder will run the weld round there. And then the inner plane tubes. So these will they'll get welded on that end in the reversal cell, and this end just get expanded up using an expander. And then so it goes flame down there, gas is back this way, reverses inside the smoke box, which we'll see next door, and then back down the outer bank. Alright, so this is a 7-tonner. So again, this is going in a higher boiler, higher trailer. So they're a little bit different, all the stuff that goes in higher boilers, because we've got to slot them down inside the trailer, we don't have any of the fittings on the side of the boiler. So you see like that one there, they've got all the level fittings on the side. On this one you'll notice there's no fittings on the side of the boiler because there isn't space inside a 40-foot Arctic to actually get any fittings on the side. It's so tight inside. So all the fittings have got to be either on the front face or on the top. So that's why these are like a special design. So this is a YSX 7000, 1004, but we do this to a 130 drawing, not 300 drawing. It's just a special drawing.
So your water gauge is on there, it'll be there. So there's the two stabbings there that come out for your water gauges. So it's normally you've got 2 sets of gauges, but on this there's 1, and then it goes into what we call a H block, which then has 2 gauges on it. So you've still got your 2 ways of checking the water. They go in there, but they go on later.
So come in here, Brendan and Dodgy loading all these tubes in. They'll get the inner bank planes, inner plank stays, stair bars in, and stair bars at the far end. Tack them all up, and then it'll go back to the welder. Then he'll weld the furnace mouth, all the bottom end, and then he'll weld all these, weld all the tubes in, and then weld all the stair bars in at this end, and stair tubes and stair bars. Once all that's done, comes back in here, we scan it again, so we scan that weld, scan all the welds in the bottom. Once that's all, we then put the outer bank plane tubes in, then it has to go onto its base. So these are what are called base saddles, you know, you were asking earlier on. So these are saddles that the boiler will sit on. So it'll sit on those saddle, those bases there will sit on those saddle points, which are,
Not on this
yeah,
one.
put them on yet, but it will do. That'll sit on them. Blank ball kitchen drop. And then we've got a little pump, like pneumatic pump, and we pump it up to hydro test pressure. So this boiler's operating pressure is 10.34 bar, design pressure 11.4 bar, hydro test is 1.5 times design pressure. So we kept it up to 17.4 bar, so I'm out now and times that by 14.3. What's that in PSI? I like to get me blown out. Anyway, I can work it out for you. It's on drawings actually, in PSI as well. Well, so we've got all the gauges in the corner, they've all got to be calibrated. We have to send them away every year or buy new ones when Brendan breaks them. And then the TUV man has to come and witness that. We have to come up with a hydro certificate, say what gauge we used on what day, at what time, to what standard, blah 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 blah. We write all that on the side of the boiler, take photographs of it, and then we have to stamp that onto the man ring on the top. So all that information, all that detail, so the boiler serial number, YSX 7000 LN 1004, standard, BS standard, EN standard that we've manufactured it to, the Byworth boiler's name, the design pressure, the test pressure, the date, gets all stamped on the man ring, so you can't get that off without grinding it off. And then the TUV man comes with his TUV stamp, which is unique to him, and stamps it, say, yes, that boiler has passed its hydro test on that date.
So as you spin that round, it rolls round and it pushes the rollers out into where you want it.
So what do you do about that side?
That's literally just a pneumatic drill.
Which is on its way here.
So it's like if you had a traction engine or something like that, or a little boiler, you'd probably just use a hand ratchet. But Brendan's got one of these. And that whizzes round. You block it with a couple of bits of bar, and then and that off that goes, sends it in there.
Expands the
But
shoe.
it's a skill to learn, because you can't just set off with one of them and just bollock on with it. You've got to know when to give up.
Are they parallel, so you end up with a slightly tapered expansion?
No,
The parallel.
Yeah,
The parallel, that's parallel, but the actual this is shaft is tapered. So the further you wind it in, the more the parallel rolls open up and expand it up.
Yeah, it's very similar, yeah. But obviously, you don't have to adjust anything. You just
You better see it on. Well, actually, when you go past that one there, if you run your finger down the plain tube, you'll feel. You can feel where it's expanded out into the hole. So what we have to do is we drill the holes at say 52 mil. We know that size of that. We know the OD of the tube, and then you've got to have a certain percentage of wall reduction on the tube to know that you've expanded it up into the hole. In theory. Or then you put pressure in it and it leaks. You've got to expand them up a little bit more.
Be millimetre if that.
Yeah, I think it stops. The idea is it stops the tube ends cracking.
Yeah.
You know when you have a, I can't remember what you call them, when you put two sections together, you have to stagger the longitudinal welds.
Yeah. So they're like 90 degrees to each other. Well, they're not at 90, no, it's like 45. So if you look at one will be. Can you see that one down there? Yeah, so there's one there, and the other one's up here. So they're like there.
Yeah. Is there an exact science to that, or is it just...
on the date will be written on the side of it. Again, it's another 7-tonner. Again, it's for this. Oh, this is Johnson Linen. It's going to Linen Company. So this one's all been done. Mud holes here. It's welded onto. This is a box section base, not stable.
So that's hydro tested, that's passed off. Boiler inspector's happy with that. That's finished. That's now a pressure vessel ready to chuck a fire in it.
Are they stayed? So they the hole all the way through?
So the hole, we're just talking about the hole in the stay. So the hole in the stay goes into the water space. Is it about 6 inches long, 5 inches long?
Yeah, the drill just so it'll go past where it's obviously the thickness of the dished end.
Yeah.
I don't know what it is exactly, but they've to go something like 15-20 millimetres past that front face. So the idea, if you've got a crack in the bar, we've drilled it that if a crack appears on the bar, the steam will get into the crack and it'll come out the little hole we've drilled in the end. It's like a telltale.
Yeah, well, all steam engines have them. The big stuff has the standard gauge stuff has those in every single side stay, back stay, throat plate stay on the big stuff.
Because it's a tube, not.
Ready to go, and then we make up so all this box here, so we call that the 600 drawing. The back end's got the 700 drawing, the shell itself 300 drawing. So each different size of boilers for its own different smoke boxes, all the parts that we need. So this is a EYX 16.5, that's 1,000. We ordered it actually at the end of last month. That's the gauges that we have to test it with. Took 17.1 bar, that's the standard we tested it to. That's all that done there. So this is waiting to go into lagging now.
We've got us brackets for his inverters, so that speeds your motor up, and then on there is a resistor bank, so you can slow the motor down on the burner really quickly. As soon as the flame goes out on the burner, you don't want that blower, that fan motor, carrying on spinning, because it's going to drag cold air into your fire combustion chamber and cool it down. So there's a resistor bank there. It heats that up all the energy goes into that. It breaks the motor really quickly. It saves a lot of the combustion gases from cooling down inside. At the back there's a little compressor bracket, so the blow down is operated by compressed air, so it snaps it open, snaps it shut. So we supply a little compressor that goes on the back. The little bracket at the bottom's for the blow down pipe. Then you've got your little manhole at the end. That's where you can get in and inspect your tubes and your bottom of your barrel.
What else have we got? This ended, obviously the burner's going to fit on there, so we weld a ring onto the end of the furnace, and then we can mount the burner mounted plate onto here. So the burner's going to blow down there. Hits the reversal cell we talked about, comes back up first set of tubes, so that's your inner bank. So that's your first pass of tubes. Comes into this smoke box. It's going to have big doors put on here, you'll see some more down there. Into this area here, and it's down the second pass of tubes, then up to the chimney at the end. So there's another smoke box welding on the other end. So this is the front smoke box and your rear smoke box. And then on the top of that we'll see the chimney welding on. And then there's just got an economizer. It's got an economizer, so the waste gas that's gone through all your boiler, it's done all your 3 multi-pass, then goes through an economizer which occupies this space here. And you've got a it's basically a heat exchanger. So any waste heat, the water comes out of your hot well, through your pumps, through this heat exchanger and grabs just that bit more heat. So with an economizer you can raise the heat from 85 to 90 degrees out of your hot well through this, and it can go into your boiler as much as 120 degrees Celsius just through that. So that saving with an economizer is massive. When you're talking 16.5 tons of water an hour that you're boiling into steam, an economizer can make you a massive saving. But we'll show you what an economizer is further down and what's inside. Again, we make all this, as I say, it's all cut, flat plate. We roll that, weld it all up, cut all the doors, handles, all the bits. This is made out of 60 angle. Again, put it all to shape, weld it all up, and the lads fab it all on the bench there. It's all sat ready. So that's 16.5. It's in the pit down there. Just wants it dished end welded on, and getting ready for hydro, which we'll be doing next week. Then these are all sat ready, so as soon as it's on that trolley through here, weld it on the end. That's the burner mounting, so that will go onto the front of the furnace, and then the burner will bolt to that, but we'll see that further down the shop. Ladders, blow down pipes, as I said, we make absolutely everything.
You see the bars tacked onto that, are they just to hold it in place?
Yeah, they're just to keep hold its shape until they'll put that, until they get it welded onto the back end of the boiler, and then they'll chop them off. Just to give it, otherwise it's all flattened out. So it gets its stiffness from being welded onto the dish end and the end of the boat and the shell of the boat. Again, this is a little, some more of these further down the shop. This is another little MX 1360. But now it's had its fabrication work done, it's had its lagging done, then goes back that way to get its door put on once it's lagged, and then it gets the door sprayed. And then that's finished, then it'll go to Pete down the shop. Again, that's one of the blow down tanks. So again, we made that in there, and it will get sprayed Amorite grey, like one of these beauties. And then we'll flange it all up, and then that's a blow down tank. These orange boxes that we're walking past, that's all the extraction for the welders.
Oh,
There's three here. They run all the factory extraction for the welding bays. So we've got a little black hood over each welding bench. Put that a metre over your head, and gets rid of all your muck, filth, fumes, and it keeps the factory nice and clean. Yeah. So these are all BT tanks that are all finished, ready to go. So this is the BT3. Again, it's got its own serial number, date that we hydraulically tested it down at the bottom of there. The pressure, we took it to 14.2 bar. Its volume, design pressure 7 bar. UKCA 0879, blah blah blah. So that's all. Then it's all stamped up on here, and that's ready to go out to a customer when they want it. Some of these are stockers. We will keep some in stock, so if they want one in there, we can. We wrap all the boilers with rough wool. Again, it's for Dodds who was in that shop in there. With a couple of lads that what they do all day. So that we wrap them in one. Yeah. So again, we wrap them with rock wool, so we don't lose as much energy out of the side of the boiler. So it's always done manually. Wrap it all, put some tape around it, holds it in position. Then we've got the stuff all aluminium zinc. So we clod them all in that, so it look pretty. So again, it's a real art to doing it. I watch them doing it, I think how the hell do they do with that? Yeah, so all this trim on it. We sprayed it in the spray shop, all Amorite grey, capping it. Two choices of colour. You can have silver or Amorite. That's it. Oh, we do want blue. We do smoke box, we smoke paint shield blue. So again, that's you talked about the inspection. You can see that there. It's the same thing. So we've welded a ring on here. We'll see further down. So basically, spring. These are made at the place I used to work at. So the idea of these, we talked about the XID tube causing turbulation of the gases as they're going down the tube. That's the same with these. The idea is that because they're just like a spring. We've got masses of them all in these things here. So all different size tubes, different lengths of boiler. We have to have different size retarders. So it slows the actual gas as it's going down the tube rather than just going in laminar flow. You've got turbulent flow, remember all that from school? So you're getting a swirling effect basically on the flue gases, and you get better distribution of heat, and it makes it more efficient. But the first lot, I think, are stainless, because they don't last longer. They don't want them rotting away. But the ones in the back are just carbon steel. But again, we have to make them that they fit. They have to be a good fit down inside of there. So I expect many years. This is, I think it's a DN 200 PN40. So the pressure is 40 bar. So it's rated up to 40 bar. So we've got PN40, PN16. So if it's a PN16, it's only rated to 16 bar. If it's PN40, it's rated up to 40 bar.
And it's 40 bar at a certain temperature as well. It's not just 40 bar on. Yeah, that'll be 40 bar at a set temperature. So we've had that before where we've had a valve and I questioned it. That shouldn't be on a boiler because it's a PN16. We really need a 30. Even though the boiler only goes up to 10 bar, that's 40 bar. But even though you've got to get the right stuff for the right heat range as well. And then plus of it, we've got to have a safety margin.
What sort of valve? What sort?
What's that rate at?
0.4 bar.
Yeah. 10.34, so 11.4. That's good. So all your boiler water needs sampling daily, twice, 3 times a day, depending on where you are. So what we do is we take a sample out of the boiler of the dirty water. So we take at midpoint, halfway up the boiler, we take a sample into there, and you've got a series of, you've got a big coil in there. You've got cold water that goes in the bottom, cold water that comes out the top, that takes the heat out of it. You open the valve, you take a little sample of water, you go do your chemistry set, and that tells you how much dissolved solids, how much oxygen you've got, how much what do you have? You have everything, lime scale, all that sort of stuff. You measure all your chemicals, then you adjust what's going in your hot well. So you put all your chemicals into your hot well, your oxygen scav to remove the oxygen, because the oxygen kills the boilers. We started making his own, haven't we? So we're buying these.
Used to make the carbon steel ones.
Yeah.
We couldn't make the stains, but we have just started making them as well. TDS, total dissolvable solids. So we take that off. So all them bits get put on there. And then we're into the main sort of finishing off section. This is a little Peaksman. We've actually had kicking around for a while. It keeps going to different trade shows and things like that. So if we load that on the back of a little wagon, take it off somewhere. So that's just a little Peaksman that we saw. It's one of the like a Virgin Clemex. So the burner's blowing in that way. Gases go down, hit the bottom, turn, come up the tubes, and then out the chimney on the top. Safety valve, ground valve, level gauges, electric panel, pump, water feeding, TDS on the outside there. Well, blow down and TDS now. Yeah.
Right, that's it. So these are your liquefied probes. These have got a vibrating fork on the end. It's same as a quartz crystal in your watch. It vibrates at a certain pitch, resonance. When they come uncovered, it knows that and shuts the burner off. So it'll stop all power to the burner, so there's no implosions, explosions. The crystals for them, there was a massive shortage of them because they mined in the Ukraine. And we didn't have them for about 12 months because of the war. And that ended production of them. So we had to move on to brass probes. So we've got brass probes, which are a really old-fashioned way of doing it, but still reliable. So you've got 2 low water probes, and then you've got a pump on and pump off. How's it pump? So normally your liquefied probes will go in the side, and then you normally have a pump on and pump off on the top. But obviously this is the old.
Customers specify what they want to do, an old-fashioned way of doing it, or small modern, or put like the controls on the one. So this is like the standard, as basic as it gets. Control system, and then at the top end, it's got our own Unity system, which is all like touch screen control and all singing, all dancing. Yeah. It's just an oil boiler, oil burner. That one again is a little bit. We don't do that many adjust oil. So it's obviously going onto a farm somewhere that hasn't got any gas. So it's some sort of food production, I imagine. But I don't know, it's just going to called Westerns. Increasing your pressure, you know, so you'll tweak it until you get the actual calibrated readings that you need. Again, I just work in here. I never go on site, but that's you know, that's what we have commissioning engineers for. So they'll go commission them on site.
So do you have to test fire in here, or do you just leave it till they go out on site?
Just leave them till they go out on site. I mean, they test fire all the ones down at higher that are in trailers because they've got all the rigged up ready to go. You see, so we've got the massive oil tanks on there. And then
They're self-sustained.
Yeah, I mean, we haven't got enough gas here to run a lot of them. And you need. Obviously you need them connected up to water, then you fill it up with water, and you need to be able to dump the heat. I mean, we can run the one, we have our own boiler, that's about a two tonner in boiler house there. So when people come on training courses, they come and they run that one up and then they blow it down, and so they can do the whole thing actually on a boiler, our own boiler house.
These are dual fuel, so these are oil and gas. So obviously their gas supply is intermittent probably. These are a bit more upmarket on the water level control, so these are a guided radar control. So you've got a radar, follows it down inside a bar in the middle, down to the bottom. When the water level comes up, the computer knows all about it, knows where the water is exactly, and then round here we've got, so if you come round this side, the guided radar is keeping the water where you want it, so you program the guided radar to keep the water at 3/4 of a glass. The computer then moderates through the mod valve the flow of water from your pumps to keep that water level bang on where you want it. So if you don't want any water carryover whatsoever, you can keep it half a glass, something like that, 2/3 of a glass. If you're not bothered for water carryover, but you're going to use a lot of it, you can keep it to 3/4 to a full glass.
So because this is going abroad, it's got two safety valves on. Two safety valves you can see up there, crown valve, water probes.
Yeah. So this is a spillback. The pumps on these, because of where it's going, will probably be on and off. So it'll moderate. They'll be on all the time. The mod valve will moderate, but then we've got that so that. How does that work, Andy? So that goes back to your hot well and heats your hot well up. So what they can do is they can keep the pumps running, they can keep them moderating the water to where they want it, they can open that back up and then put water back into the hot well to heat the hot well up.
It's called a spillback.
A spillback. So it's just a different. Some you don't really need them, but they seem to like them in Bangladesh, so we put them on. Air controlled again, so you've got this doesn't have a compressor, but you've got a compressed air supply, opens the blow down, snaps open and shut that. Economiser on the back, two nice Gumpers pumps. They're not cheap, which is unusual for an export job. They usually have everything on the cheap, but this isn't. This is quite a upmarket one, isn't it? For a change. We've got another panel there with all the bits in, if you want to have a look at that. When these go to the customer, you've got all your instruction books, just like we get when we get something from MFI. We've got all the bits on how to put it together and fix it. And then we've got a full set of drawings, so all the electrical drawings go in there, and then electronically we'll send them all the document pack that we've got for the boiler. That'll all go. When I get the boiler, we get a GA, we get I get a route card, so I've got, there's me on it for burner mounting, me on it for assembly, electrical assembly, I know who's on that. I've got running copper, so that's another lad, he can book onto that. And then we've got paint rework, so the painter comes along, he can log back onto it, and we can electronically book time for that, so the customer's going to get an accurate reflection of what he's spent his money on, but then we can then plan how many hours we've spent building that. So the next time we build one of them, we know how long it's going to take. So then we can forecast exactly how quick it's going to come from the cutting shop all the way through to it being wrapped. So these routes now are driving the business. And then I get a GA. Some of them are a bit of a wish list. We have to make it up as we go along. But I'll get a pipework drawing. So the pipework for that is there. That's been a sub-assembly. So we've ordered all the bits. Well, the design engineer's ordered all the bits. I've told him what will and won't work, and then we get a bit of a GA for the pipework. We make it to suit the boiler.
Is that the solid works?
Solid with the shipper, mover and shipper handle on that side of it.
We do sometimes. That boiler about that big we have in the past, they'll turn up with just send a shipping container, and we've got to skate it into back it.
Yeah.
So
they're going on Wednesday.
Right.
So they're going on Wednesday. They'll be stripped and wrapped, shrink wrapped, and put in a convertible roof shipping container, 40 footer. And I know that they're a tight fit. They are tight. They're like a couple of inches either side of them. That's straight in.
A different process. This one probably go back to the hot weld tank. If they need be, so they can join 2 or 3 different boilers together if you want. So these come in various sizes, obviously depending on the size of the boiler. But again, it's a piece of tube. We'll have to cut it out. We weld all the fittings in. We make all the fittings, weld all the fittings into it. Put it on. Then they're to pressure test as well, and they all get their own unique number. So they're all done to a drawing, to a standard, tested to a certain standard, manufactured, all traceability. All same, just as like making a mini boiler, but not as exciting. Getting a burner on.
The little tube at the bottom is a sump for condensate. So if you've got condensation in your water lines, so this is all steam heat pipework up here with a drop at the end, and that's to collect the condensate. So what happens if you've got condensate in there? It rattles up and down the pipes till it starts evaporating. So when it's cold in the morning, it'll bang, and it'll shoot the other way, hit the flange at the other end and go with an almighty bang. Well, it can blow the ends off pipes. Even whatever rating you've got your pipework at, it can blow them off. There was a guy in America, in New York, they've got street heat, they've got the heating throughout the streets, haven't they? Yeah, district heating. There's a good video of a guy down in the manhole. He's opening up this valve to feed another part of the district, and then all the lads start screaming and shouting, and all you hear is a tink, 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 and that's the steam, the water hammer, and then he gets blown up out of this manhole. He survived, he landed on the floor, but it blows him right up into the sky, and that was just a little bit of condensation. So that, as insignificant it is a bit of a lifesaver for your factory, because that's going to collect all the condensate, and it actually pushes that back into your hot well. So you're not going to lose that water. That gets pushed back through steam pressure, through a steam trap, into your hot well, back into your boiler, back into your steam header. So you're never going to lose that water. Closed circuit, you're never going to lose that water. So is that doubled or tripled? Yeah. Electric price, so that's...
I mean, I think the price of steel has come back down again a little bit. So it's
stabilised.
Yeah, it goes when it comes back down again. So they have to keep they work it out price per ton. So obviously sales they have to keep. Eventually, so as I said, we'll put an oil tank over the neck, and then a hot well, and then they can get access into the little doors, and then the boiler will go in through the back door. So the idea of these units here is that we can back each of those trailers into these, and then the lads can work and deliver the boilers down as well to it, and then get it into the shed, and back the trailer in and lift the boiler in through the back doors. That's the idea eventually. Yeah, so there's Tiger trailers and all out of there, put it into here. Then knock that shed down, then build the rest of this, and then eventually all this stuff is at this end of the shed, or have to go to that end. So it's a bit of a pain.
That concluded the tour around the Byworth boiler works at Keighley, and I must say we're really impressed, especially the high standard of workmanship and the variety of boilers which are produced here. Obviously they don't make the traditional riveted type boilers, which a lot of people are used to seeing. These are the more modern, all welded boilers, and seeing some of those welds, they're amazing. It's nice to see signs also with things made in Britain, and this company, everything's made in house. Amazing to see the different kinds of boilers they make, from quite small ones, portable type, to the large size ones, and a variety of companies which use these boilers. The thing I did like though was to see the signs there saying "Made in Britain." Made in Britain is getting to be scarce these days, because everything seems to be imported. But when you see that sign "Made in Britain," it really does. It does say it all. Well, I hope you found this video of interest, and thank you for watching.